Electrochemical cells. Here we're creating electrical energy from potential energy in reagents. Electrochemical cells, sometimes called voltaic cells, either term is acceptable. They create electrical energy, converting energy from spontaneous exothermic reactions. In a voltaic cell, we use a chemical reaction to produce electricity. Now, there's another cell type. In an electrolytic cell, we use electricity to break up a compound. The cell types are opposite. I'll do separate videos on electrolytic cells and comparing the two types. Okay, so voltaic cells. The chemical reaction has to be spontaneous and exothermic to liberate energy. A voltaic cell uses a redox reaction to generate electrical energy. If you like, a voltaic cell produces volts. Oxidation and reduction reactions are carried out in half cells, which are kept separated. The simplest half cell consists of a metal dipped into a solution of its own ions. Now, an equilibrium is established between the metal and its ions. We would find that metal particles on the surface would go into solution, releasing electrons, and metal ions already in solution would accept those electrons and become deposited on the surface of the metal. But I have two half cells, and they're then connected by a salt bridge to make my voltaic cell. Here I have my two half cells, one with zinc in contact with zinc ions, the other with copper in contact with copper ions, connected by this salt bridge. In the zinc half cell there's an equilibrium, the zinc metal in contact with zinc ions in solution, and the two changing places. Similarly, in the copper half cell we have another equilibrium. Copper metal atoms going into solution as ions, ions taking their place. Zinc is more reactive than copper, and that means the equilibrium in the zinc half cell shifts and zinc metal goes into solution as zinc ions. We see that here. The zinc metal going into solution now as zinc ions. It's a one-way street. The equilibrium has been shifted. Electrons are produced. They will travel around an external circuit to get to the copper half cell where copper ions accept them. And here that means that reduction is happening. My equilibrium in the copper half cell has been shifted so that the net process is my copper ions accept those electrons and become reduced, forming copper metal. The movement of electrons around the external circuit generates electricity. And I've got a voltmeter, a high resistance voltmeter in there to measure how much electricity is produced. So, the electrons lost travel around the external circuit to the copper electrode. Here, copper ions in solution accept the electrons and become deposited as copper atoms. We haven't mentioned the salt bridge yet, but the salt bridge contains a saturated solution of a very soluble ionic salt. Why very soluble? I'll have so many ions in there ready to perform their function. The zinc ions going into solution in the zinc half cell need to be balanced by negative charge. Negative ions from the salt bridge diffuse in to do this. Copper ions lost from the copper half cell are replaced by positive ions from the salt bridge. The salt bridge preserves electrical neutrality. That last sentence really sums up the function of the salt bridge. Now, if the salt bridge was potassium chloride solution, chloride ions would diffuse into the zinc half cell to balance the extra positive charge of the zinc ions. Potassium ions would diffuse into the copper half cell to replace the copper ions lost. Oxidation occurs at the anode, the negative electrode. Let's stay with that for a second. I see in the zinc half cell. Oxidation happens as zinc atoms are oxidized to zinc ions. The fact that electrons are produced here makes this the anode. Oxidation happens at the anode. Reduction occurs at the cathode, the positive electrode. Looking at the copper half cell, copper ions here are reduced to copper. They're accepting electrons that have moved around the external circuit from the zinc half cell. The electrode is positive because positive cations are attracted there. It's the cathode. Again, in the zinc half cell, zinc ions are formed and electrons are produced. This is the anode as negative electrons are produced here. Anions from the salt bridge diffuse in to balance the extra positive charge. The zinc atoms that lose electrons are being oxidized to zinc ions. In the copper half cell, copper ions are reduced to copper. Cations diffuse in to replace the lost positive ions. Cations diffuse in from the salt bridge. This is the cathode. Reduction occurs here. Cations are attracted to the cathode. Two quick questions to finish off. Draw a label diagram to show a voltaic cell made of an iron half cell and a copper half cell. So 4 points. I need to draw my two half cells with the metals in contact with solutions containing their ions. Charge on the Fe ion given in the question. That's 2 points. I need my salt bridge in place for a third point. I need my flow of electrons through the external circuit. Good to show that the anode is the site of oxidation, the cathode is the site of reduction. Half equations for the reaction taking place at the anode and cathode. Iron being the more reactive metal, being oxidized to form Fe+2. Copper ions being reduced to form Cu. And the direction of electron flow from the anode, where the electrons are produced, around the external circuit to the cathode, where they're accepted. One more. Another configuration. Another voltaic cell. This time we've got a compound containing silver, Ag, with zinc metal. Explain the action of zinc in the cell. Well, if I look at the zinc, starting off as metallic elemental zinc, ending as zinc ions. The zinc is being oxidized. If it's being oxidized, it's acting as the reducing agent. That means that I am down now to A and B as options. Now, the zinc being the reducing agent, we've now got to consider where the zinc will do this. Will it do this at the cathode or at the anode? Well, I'm looking at my silver ions for one thing. They are attracted to the cathode. That in turn must make zinc the anode. Or I could say the anode is the site where electrons are produced. They're produced as zinc loses electrons to go into solution, allowing those electrons to flow through the external circuit. That's it. If you got anything out of that, please like, please subscribe to be notified of more content.